Okay, so from the above discussion that we got clarity what is a function, what is function call, and what is function definition. Then we will go to the next point, that is recursion. So this is one of the important point. So what do you mean by recursion? Recursion means one point I'm writing when something is defining in terms of itself is known as a recursion. Something is defining in terms of itself, that is known as recursion. So what is the meaning? Suppose, for example, I will say we will find the factorial of a number. We will find the factorial of a number. Suppose I will find the 5 factorial. So I can write 5 into 4 into 3 into 2 into 1. Factorial of a number. So it is nothing but a series multiplication. So this series multiplication, I can write in another way 5 into, so this 4 into 3 into 2 into 1. So I can consider as 4 factorial. I can write 5 into 4 into 3 factorial. I can write 5 into 4 into 3 into 2 factorial. I can write 5 into 4 into 3 into 2 into 1 factorial in this way. Or 5 into 4 factorial you consider. That means I am finding the factorial of a number by taking the concept of factorial. So that's why I wrote that line. Something is defining in terms of itself. I am finding the factorial of a number by taking the concept of factorial. So that's why we can say it is a recursion. So if 5 is n, then 4 is n into, sorry, n minus 1. So n into n minus 1 factorial. So this is the logic. Okay. So this is one of the important point in function. What is a recursion? And we will take an example for better clarity, for better understanding. So now coming to the point, so I can write Python program to find the factorial of a number, the factorial of a number using a recursion, using recursion. Python program to find the factorial of a number using recursion. So first of all, I will define a function. So let my function name is factorial. Okay. So one function, same concept. Always to resolve the task using function context, we will represent a function definition, then we will represent a function call. So I will develop the application any number, factorial of a number. So here input is 1, output is 1. So any input value when I will take, so I will get the factorial of that number. So first of all, I will define a function. Let my function name is factorial, and within bracket, so already I have told, so number of input, so that is number of arguments. So number of input, suppose one input, so as per the analysis, so that's why I took one argument. Now I will write the logic. Logic is very simple, n into n minus 1 factorial. But this logic will be valid for every number but upper two number. That two number is what? If the value of n is 0. Okay, if the value of n is 0 and if the value of n is 1. So 1 factorial is 1 and the 0 factorial is direct 1. There is a formula. So I can represent here, if the value of n is 0, then return 1. Return 1 means return is a keyword, particularly in Python function context. This is called as return statement. That means output is 1. Now I came out from the if block. Else if the value of n is 1, if again return 1, then else as usual we will write our business logic. So I presented, if the value of n is 0, the factorial is 1 or output is 1. Else again if the value of n is 1, then factorial is 1. So apart 0 and 1, we can consider if any number, then that logic we will implement return n into factorial of n minus 1. So this is my logic, and this is my function definition. This is my function definition. So now I will come out from the function. So this function definition representing factorial of a number, I will explain. I will show you how the control will iterate. What is the flow control? Now, when a function definition is executing, when a function that we will call. Now, I will call a function. So factorial. So within bracket, suppose I will take a variable x. So this x is actual argument, n is formal argument. So what is x? So the value of x I will give at the runtime through the keyboard. So input function that I will call, enter the number. So within input function, so within double quote, whatever we will write, same message will display in output screen. So my target type is int, so that means I will give int value as input value. So everything is ready, but till now I have not written any output statement. So it is mandatory that I have to write output statement. Without output statement, because output is not coming to our picture. So I have to write the output statement. So this function call I will write within output statement. And for decoring, so within double quote, I can write the factorial is this. So within double quote, the factorial is this, and you see, so this is a function call. Function name, parenthesis, within parenthesis, there is an argument. So this is a function call. So this is actual argument. X is actual argument, n is formal argument. But in function context, actual equals to the formal. So whatever the value of x that I will take at the runtime, so that will be the value of n. Okay, so any number that I can provide, then I will get the factorial of a number. So first of all I will run and we will see so that output is coming or not. Then I will explain in which way that the control executed or what is the flow control. Now I will hit run. You see, so message came, enter the number, any number I can give. Suppose I will put 4, enter. The factorial is 24. Yes, so any number, suppose again I will hit run, enter the number, suppose 6, enter. The factorial is 720. Again I will hit run. So enter the number, then I will give the value 5, enter. The factorial is 120. That means any input value we are providing and we are getting the factorial of a number. So when I will give the value 5 at the runtime, so this 5 is the value of x and x is actual argument. So if the value of x is 5, so that will be the value of n because we have written. So actual argument equals to the formal argument in function context. Now the value of n is 5. So when a function will call, then function definition will execute. You see, now I copied, just I will explain in which way that control is understanding. So I will explain. So this is my code and you see the value of n is 5. So now it will be execute. So if 5 double equals to 0, false, then this statement will not execute. Control will come to this line, 5 double equals to 1. Again, it is false. This statement will not execute. Then else part will execute. So what is else part? Return statement. This is output statement. Return n. The value of n is 5 into, so n into factorial, n into factorial of n minus 1, 5 minus 1, so that is 4. So this is the first output statement. But 5 into factorial of 4. So when the control will read these things, so when the control will read 5 into factorial of 4, but factorial of 4, it is control will read, you see, it is looking like a function call. Function name is factorial, parenthesis, and within bracket a value is given, a argument is given. So particularly it is important, guys, you remember when the control read 5 into factorial of 4, this factorial of 4 control will treat it as a function call. And the concept is saying anywhere if function is calling, then control will go to the function definition part. So now if this is a function call, this is a function call. So control will treat this is a function call. So now immediately anywhere a function is calling, the control will go to the definition part. Now this 4 is actual argument, n is formal argument. So now the value of n is 4. So again it will execute 4 double equals to 0, false. 4 double equals to 1, false. Again return statement, else statement will execute. So 5 into 5 came to the output, 5 into, for factorial of 4 I will write, so the value of n is 4. So for factorial of 4, so return n 4 into factorial of 4 minus 1, that is 3. So now control will read this is a function call, factorial of 3. So 5, this is the output statement, 5 into 4 into factorial of 3. So this is output. So factorial of 3, again control will treat it is a function call. So now 3 is actual argument, n is a formal argument. The value of n is 3. So when a function will call, again the control will go to the definition part. Again body will execute. Now 3 double equals to 0, false. 3 double equals to 1, false. Again this statement will execute. 5 into 4 into, for factorial of 3, n 3 into factorial of 3 minus 1. 3 into factorial of 3 minus 1, 3 minus 1, that is 2. So factorial of 2. So again this is a function call. Again this is a function call. So now the value of 2, the value 2 is the value of n because 2 is actual argument, n is formal argument. Same way it will execute. Again control will go to the definition part. When a function will call, then function control will go to the definition part. 2 double equals to 0, that is false. 2 double equals to 1, false. Then n into 5 into 4 into 3 into, then for factorial of 2, so then n will 2 into factorial of 1. Factorial of 1. Then again factorial of 1 is a function call. Then again it will execute, value of n is 1. 1 double equals to 0 false, 1 double equals to 1, it is a true, then return 1. So factorial of 1 is 1. So output is 5 into 4 into 3 into 2 into 1. So that is 120. So in this way, the control is understanding, or this is the flow control. Okay, so when a function is calling, this part control will treat as a function call. So when a function is calling, then control is going to the function definition part. Again, it is executing. So it is a what recursive call, means this function is calling to itself. In this function definition, there is a function call. In this function definition, there is a function call. That means another point we can write also, when a function is calling to itself, that is called as also recursion. So in this way, the control is evaluating. So as a result, we are getting this output. So this is called as recursion. When something is defining in terms of itself, that is recursion. And we saw in recursion context, function is calling to itself. So that is also recursion. Right? And I hope you got clarity, because I took an example, the factorial of a number. So factorial of a number, so that we found by using the concept of recursion.